guys, so we're going to get started with our live coding for this asynchronous 2 session on for loops. So first, a little bit of context. So in my classroom, I would use live coding as a way to deliver new content as well as to review prior concepts. Students would be coding along with me, whether it's in Scratch or in REPL or whatever IDE we're using at the time. And this would normally come after the do now and opening procedures, but before a challenge set or some other coding assignment. Live coding can feel like a blend of a think aloud for new content that I want to model, and also a we do for older content that I want to spiral in. The most important thing though is to include frequent checkpoints for your students so that they can update the code, their code at their seats, and also help each other to debug small chunks of code along the way, so that by the end of the live coding, every single student has a working program or several working programs that they can use as a reference later on. So let's get started. You should have a blank REPL screen open, so you should have created a new REPL so that you can code along with me. And then at certain points, I'll ask you to pause the video, try something out, and then restart the video. So we are going to be talking about for loops today. The key idea is that we use a for loop when we know how many times we want our code to execute. So this is different from a while loop where we don't know how many times the loop will execute. For a for loop, we actually do. So let me give you an example and show you the syntax. So to set up a for loop, you type for I in range, and then in parentheses 0, comma, say 10, and then you put a colon, and then you press enter, and you should be indented, and I'll just say print hello. Okay, so let's go ahead and see what this code does. I'm working in idle, which you guys will work in a little bit later in the course. So I'm just gonna go ahead and save here. You should make sure that you save your REPL, and I'll run it. And what I see is that hello prints out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Pretty cool. So it looks like what happens is that the indented code executes for every value of I in this range. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 10 times, and I actually stops before it gets to 10. So if we wanted hello to print out 100 times instead, this is now super easy because we can just change the 10 to 100 and then run our code, and we get 100 lines of output. So that's way easier than typing a print statement 100 times. So that is a for loop, okay? So here's some terminology for you that you might want to take down in your notes. So I is called the index variable, and it gets updated after each iteration of the loop. So what that means is that I starts as 0, hello gets printed, and then I gets updated to 1. And since 1 is still smaller than 100, hello gets printed again. Then I gets updated to 2, which is still smaller than 100, so hello gets printed again, etc. All the way till I reaches 99, which is still less than 100, hello gets printed, and then when I gets updated to 100, that's not less than 100, so the loop stops executing. And that is basically how a for loop works, okay? So something that is interesting to do, and you should do this in your code, is to actually print out the value of I before the word hello, okay? So I'm just gonna put I, comma, so that should print out whatever the current value of I is along with the word hello. And I'm gonna change this range back to 10 just so I don't get a ton of output. And so you can see what's actually going on is that the first time I gets printed, it's 0. The second time I gets printed, it's 1. And then the last time I gets printed, it's 9. So that's exactly how we said a for loop works, okay? So at this point, you should pause the video and go ahead, write this loop in REPL, make sure when you execute it, you get the same output. Okay, so something else that you can try is to change the loop header in different ways. We're going to keep printing out the value of I so we can build some intuition as to what's happening. The first way I'll change the loop header is by inside the parentheses sticking a third argument in, and I'll put 2. So let's run this and see what the effect of that 2 is. So save, execute. And I see what's happening is that I is going from 0 to 2 to 4 to 6 to 8. So this number 2 is actually called the step, and that is how much I increments by each time. If you do not indicate a step, it's assumed to be 1, which is what we had before. Let's try one more. So you can also go, instead of from 0 to 10, you can go from 10 to 0, and then your step would have to be a negative number so that you count down, and we see we start at 10 and then stop at 1. Again, we never actually hit that end value of the range, okay? So here's what you guys are gonna do now. So your task is to write a for loop that counts from 25 to 100 by 5s. You should pause the video to write this code, and then when you restart the video, I'll show you how I did it, okay? Good luck. Great, so hopefully you've got some code there. So here's how I did it. For I in range, I'm starting at 25. I wanted to count up to 100, so I have to go at least one past 100 in the range, so I'll go to 101. And then my step is 5, and I'm just gonna print out the number I. And we see I still have the previous output because I forgot to clear my shell, but then I go from 25 to 100. Okay, so that is good. Just one note is that this index variable I is just that. It's just a variable. So you can actually change this to anything. I can change this I to Allison as long as inside the body of my loop I also refer to Allison as my variable. And you see it still works. Okay, so the index variable is just a variable. It can be called anything, but I is a fairly standard name that you will see. Okay. So I want to show you a new example. I'm going to just delete this. You don't have to delete anything. Of calculating a sum. So this is a pretty standard application of loops that will come up in lots of different challenges that you do and your students do, and in pretty much any real world program. So what we're going to do is calculate the sum of all the numbers from 1 to 20. So what that means is we want to do 1 plus 2 plus 3 plus 4 all the way up to 20. Okay, that's what we want. Okay. So if you want to sort of think this through, this is going to be similar to previous loops, except that instead of just printing out all those numbers, I want to add up all the numbers. So a strategy that we're going to use is to define a second variable and use it to keep track of the running sum, so that as I updates, the sum also updates. So let me show you what I mean. So first we're going to initialize a sum to 0. So I'm going to create a variable called sum, set it equal to 0. So now, just like before, I'm going to loop over all numbers from 1 to 20. So that looks like for I in range, 1 comma 21, colon. Now, before I actually go ahead and do anything to I am going to update the sum by adding the current value of I to it. So I'm going to take the old value of sum and add I to it. That's over here. And I'm going to make that my new value of sum. So I'm updating sum. Okay? Now, just so I can see what's going on here, and you want to do this with your students as well, you want to print out both variables so that you can build some intuition as to what's happening with sum and what's happening with I as you iterate through the loop. So to do that, I'm going to print out the letter I and then whatever the value of I is. And then I'll do a little tab and I'll print out the word sum and then whatever the value of sum is. Okay, so let's run this and let's see what's happening. And then you can pause the video and write the code yourself. So I starts at 1, which is what we expected, and at that point the sum is just 1. So then I got updated to 2, and then sum increased by 2. So sum is now 3. I then got updated to 3, and sum increased by that I value of 3, so sum was now 6. I got updated to 4, so sum increased by that I value, which was 4, so sum is now 10, etc. So we can see that that line, sum equals sum plus I, is taking this old value of sum, 6, adding the new value of I, 4 to it, and getting a new value of sum, which in this case is 10. And it goes all the way up to when I equals 20, and the final sum is 210. So you can go ahead and pause the video now so that you can write out this code, make sure that it works for you. Okay. Great. So hopefully you got that code working. So now I'm going to give you one to try on your own as a check for understanding. You are going to calculate the product of all numbers from 1 to 20. So instead of the sum. So it's going to be 1 times 2 times 3 times 20. And you want to do this using a for loop and using a second variable, which in this case you should call product. Okay? So go ahead, do that, give it a try, and then when you're done, you can restart the video and I'll show you how I did it. Great. So let me show you how I did this. So here we need a second variable, which I'll call product because it's going to be keeping track of a product. Now, what I'm guessing a lot of you tried, or at least what a lot of students will try, is they try the same thing. So they initialize product to be 0, and then they basically do the same thing as before for I in range 1 to 21, and then they do product equals product times I, because now you want to multiply together all of those consecutive values, and then they do print I, tab product. Okay, so that basically looks similar to the code from before, except that our variable is called product, and each iteration of the loop we're multiplying in the next value of I to the old product to create a new product. And let's actually see what happens there. Whoops, I should have cleared the shell. But it starts here, and what you can see and what your students will see is that the product each time is 0, even though I is updating correctly. So what's going on here, the mistake is that if you start product at 0, no matter what you multiply in, anything times 0 is 0, so the new product will always be 0. And that's what's happening there. So you can sort of guide students through that with some questions. What happens if you multiply 1 times 0 and then 2 times 0? And they'll see that ultimately the product will always be 0. So how can you fix that? Well, you can just initialize product to 1, and we'll see how that works. And there it is, and we see that this product gets huge very quickly there, okay? Oh, I see what's happening. I still have my other for loop for my sum up here, which is why I'm getting this sum output every time. And I apologize about that. Okay, perfect. So this is the end of the first content video for Asynchronous 2. There is a second video that will include the second part of live coding, so I will see you soon.